In this chapter, we look at vectors. A vector is a directed line segment. Here we have vector PQ, which is a directed segment, and P is known as the initial point. Q is known as the terminal point. A vector has two things, direction and magnitude. So direction is the direction of the arrow, in this case pointing from P to Q. Magnitude is the length of the line segment. Example of vectors will be like velocity, gravitational forces, magnetic fields. Because a vector has both direction and magnitude, two vectors are equal if they have the same direction and same length. So the two things must be both the same direction, same length. The magnitude of a vector A, right, denoted by magnitude A with two vertical bar, or A with two double vertical bar, is the length of the vector A. On the xy plane, right, if A has coordinate x1, y1, and O is the origin, then the position vector of A is written as vector OA, and you use small a to denote. When printing, we can print it bold, right? If you write it as A with a tilde below. So OA is the position vector of A. The position vector starts from the origin O. And magnitude of A, right, is given by square root of x1 squared plus y1 squared. And this formula came from Pythagoras theorem. So if you have A is x1, y1, this length will be x1, the vertical length will be x2, will be y1. So will be y1. So Pythagoras theorem says that x1 squared plus y1 squared is OA squared. So OA will be square root of x1 squared plus y1 squared is OA, which is the length of the vector. So for the vector OA, which is 4, 3, so the length of vector OA is just square root of 4 squared plus 3 squared. So it gives you square root of 25, which is 5. You also write this as OA with a magnitude. Okay. Next, we can write vector OB. So we can talk about magnitude of vector OB. So it will be denoted by small b, and will be just square root of minus 8 squared plus minus 15 squared. So it will be square root of 64 plus 225. So it's square root of 289, which will give you 17.